Yeah, think we can start right now. Yeah, hello all. Today we'll discuss about the uh, week 7 topic. So in the week 7, Dr. Pavita has been taken lectures on the clustering, and we'll discuss about some questions related to the clusterings. First of all, we'll discuss what exactly the clustering is, and uh, then in our further discussion, while discussing the question, we'll along with that we'll also discuss particular concept as well. So as we know that clustering is an unsupervised algorithm. So what is exactly an unsupervised algorithm? So unsupervised algorithm which does not have an y labels, or we are only looking into the distribution of the data. So in previously in SVM, decision tree, and ANN as well, we are training, or we are considering the labels of the data points. Based on the labels of the data points, we are training or our algorithm, and based on the labels, we are trying to find out patterns. What exactly the pattern is followed by for a particular class, right? So the SVM, as we have seen that there is an two classes are there, and so these two classes we have considered, that is an these classes depend which are the labels of the data points. So each of these points has an data points, right? So this is an x1 feature and this is an x2 feature. So we have considered their labels, and based on training labels, and based on this training label we are trying to find a pattern. So from this data we are trying to find a this separate boundary line actually, that will consider, or that will be used to further classification of the new points, right? So that we have seen the uh, process in the supervised algorithm, right? In simple words, the supervised algorithm requires uh, which uses the features, independent features, along with the labels, associated labels, right? So this is an object 1, object 2, object 3, and this is a label for object 1, y1, y2, y3, right? So this data, labeled data, is used for the supervised algorithm, right? And in unsupervised algorithm, we have only the X part. Right? In some cases, if there is a Y part is also there, but that will be used only the testing purposes. While training the machine learning or any algorithm, we are only utilizing X attributes, that is only independent features. Based on these independent features which has an multiple objects, object 1, object 2, object, we are trying to find out the distribution or in patterns of these objects. Let's plot this X independent features on the 2D plot, right? X1, x1 and x2, and these are the, we don't know the labels of this each of the point right now, only needs to consider this part. Okay, forget about this while. Okay, so we are trying to map these X features into a 2D plot. 2D, why we are taking a 2D? Because right now we are, for simplicity, we have taken only the two features. We have considered as in two features are there, two attributes are there only. Okay. There might be greater than two features. So in that case, the dimensionality will be increased. So we can plot it such a way that, so you can see I have not used a cross and the circle here. Only all of the points has been considered as a circle because we don't have the labels of this data points. Okay. So from this distribution, we are trying to find out this is a one class because it is closely represented or mapped here. This is a one. This could be one class, which are the closely distributed and mapped in the 2D plot. So as we have seen the basic concept of the clustering, but where we can use this concept, that is one question, right? What is the applications of the clusterings? Right? So we have, let's take as an yesterday's and last discussion, we have also taken one example which is about the car mm, or vehicle features you have, and you have a label. Based on that, you are training your model. Let's take a similar example in this concept, in this context, which is, and you have a different vehicles. So we have a vehicle data, right? In the vehicle data, the X represented as in multiple attributes of the vehicle. Attributes X1, X2, X3, X4, so on, Xn. Okay, for each object. So this is object 1, object 2, object 3. Here, the context of the object 1 is an of one single car. This is a car 1, object 1, car 2, object 2, car 3, or any vehicle, object 4, right? So we need to study these attributes, okay, and we have mapped in a 2D plot, okay, and we got like this way structures, right, based on these attributes, okay. Okay. So then we need to learn our clustering algorithm, and clustering algorithm gives a clusters. How many clusters could be possible here? Or you can give a hyperparameter. Some of the algorithms require how many clusters you want, right? The clusters maybe that depends on the application. So for this vehicle or car, for wheel vehicle, there is an two categories. Let's take as an example. There is a car and there is a truck maybe, or anything, right, which has an only four vehicles, right? So that does not follow another category which is about the two wheels, right? So here, the based on that, it makes a clusters of it. After observing each of the clusters, we are trying to find that, okay, yeah, in these clusters only the car data points has been incident. In these clusters only the truck vehicles has been incident. In this way, it is an two wheeler bikes are introduced. In this three wheeler, like this way, okay. So this can be used in many applications, okay. So let's take as an example, or another example. We have a discussion on your Twitter, and you have lot of such objects, okay. This is one post, second post, third post, fourth post, okay. So we have n posts are there. This object one means one Twitter post, object two, second Twitter post. Like this way, you have n posts are there, Twitter posts are there, which is in, let's consider only the text part of the Twitter post, and you mapped in a in coordinates, and you are getting closely points which are discussed about a single topic or a related topic, okay. Similar way, another points has been closely related to each other. Why they are closely related to each other? Because they are discussed about the somehow similar topic. So based on that, we can do a clustering. So this cluster is discussed about. We can find a inference from this clustering. This cluster is this number of posts as discussed about the Agnipath scheme. This cluster is discussed about the Kashmiri Pandits controversy, like that, or things like. So, like this way, we can use in many applications the clustering part. I hope you guys understood the basic things about the clustering, why we require the clustering, and how we can do it. The clustering, that is, in further slides we can discuss. We have unlabeled data. By using this unlabeled data, how we can find out cluster formation. Okay. Okay, let's move to the first question. Question first states that a good clustering is one of with dot dot. So we have four options here, right? And so we need to find out which criteria is suitable for a good clustering. Uh, Please first you may think about which one could be the best one, or it's better one, and please let me know. After that we'll discuss it anyway. Okay. Yes, anyone has got the answer? Anyone? Okay. So let's discuss it. So this is an actually maybe uh, so it is an evaluation strategy, one of the, right? So how we can decide whatever the clusters we have incorporated or we have found, they are good enough or not. Okay, so there might be many possibility, right? So in suppose you have a, let's uh, let's visualize you have a 2D plot and you have represent all the data points in the 2D plots. That is an user defined, right? And in some algorithms it calculates within itself much the cluster in this data has. Okay, and some algorithms like k means clustering, which has you have to give a k parameter, how much clusters you want. Okay, and suppose you have given three, you want a three clusters from this data. So after getting a three clusters, we need to also verify that these three clusters has been identified a particular algorithm which are correct enough or not. Are you understanding? So yeah, so that is a cluster we made that is closely connected to each other on, and which is also not closely in the two clusters not closely enough. So okay, might be you are getting confused. We'll visualize here. Okay, suppose you have a distributed point like this way. Okay, so there might be a, say you may see that. So here is might be one cluster, this one is my one cluster, this one is my one cluster. Another possibility is here as well, that is, and suppose we have this one is also maybe one cluster, this one is also maybe one cluster, right? But we need to identify whatever the clusters we have made here, right? The clustering, the strategy of the clustering, that we have seen in the lectures, right? That is an There is a two way we can do a clustering. The first is an partition way, and another is an hierarchy way, right? In the partition, we have seen that the clustering we can do by using the k-means clustering, right? Partition means it is directly finding a centroid, and based on the centroids, whatever the closest points are goes to a single clusters, right? Similar way, the closest point, the neighboring close inner points goes to a single another clusters likewise. And in hierarchy, what we have uh, discussed, so we have suppose 100 points, so each points we considered as a single cluster in hierarchy. Then we are merged two points if their distance between the 2 points is close. Okay, so likewise, we merged the 2 points. After that, we merged these two clusters. Based on the distance of the two clusters is close, then we have merged this as well. Like this, then merging the all of these points. Right. It is an bottom up and also top down approach we have seen. Right. So this is the two way we can do a clustering. So in partition, there has been two algorithms we have seen, that is in k-means and the db scan. And in hierarchical, we have seen uh, the two algorithm, that is a bottom up and assertive, and that decisive algorithm, right? That is in bottom up, you can uh, consider firstly all the data points as a single cluster, and then you are merging it, and at the end you will get a single cluster, right? And here, that is an if you want two clusters, that is an hyperparameter, but depends on the user. So you can cut at the second level, which you will get the first cluster, and this is the second cluster, right? This is first and understood. Similar way, in the k-means, we have give to uh, k parameter how much clusters you want. So based on that, it decides two centroids. Based on these two centroids, it trying to find out the cluster. DB scan does not require the hyperparameter from the user. It will find out the clusters based on itself algorithm actually. Okay. So where we are, so we need to, yeah, if when the algorithm, any algorithm has been created, the clusters, we need to evaluate that the particular clusters has been made by the user, the algorithm, it is an uh, good enough or not, right? Might be three is a good clustering, right? The fourth is a good clustering. Here, let's see how we can evaluate. So first option states that how low inter cluster distance and low intra cluster distance. So here I will explain what exactly the inter cluster distance is, and another is an intra cluster. Inter cluster means that is a distance between the from this cluster to this cluster. What is the distance between this uh, points, right? So this points to this point, this point to this point, this point to this point. This is an intercluster distance. And intra, it is an distance between within the cluster itself. So whatever the points fall into the single cluster, that we need to find out their distance. Right? So first, it is stating that in the first option, they are saying the distance of intercluster means that is a distance in between the cluster is low. Are you understanding? Is low means these clusters are very close to each other, right? But what we want actually, we want a clusters which are explicitly distinguished to each other. Explicitly means their distance between one cluster to another cluster, in between the clusters the distance should be a large, right? And the distance in between the points in within the cluster, it is an minimum. This is an large, and this is a minimum distance. So in that case, we can say that, yeah, this is an good cluster distribution here. Uh, Clusters we have found here. You can see here, while we are considering k is equal to 4, that is, and if we trying to get a 4 clusters, that uh, we get a lower score actually. That is, and you can see here the inter cluster distance is very low here, right? In this point, maybe I will use the color. In this point, intercluster distance is very low. So maybe we can say that we got as in 4 clusters, but it is not sure about this is a good clusters. Okay. So here the another point is states that low cluster intercluster that we don't want. We want a high cluster distance, intercluster distance. In between the clusters, we want a higher distance, right? So in the answer could be in this in between these two options actually, right? This condition is we have satisfied. So we need to see the another condition, low intra cluster distance. Yeah, that we want actually, right? Intra cluster means within a cluster, whatever the distance we are getting from each of the point, so this distance could be lower, means they are closely connected to each other, closely uh, uh, represented to each other. So that's why that defines that they are strongly interconnected, so strongly related to each other. If they are furthest, they are not closely related to each other, right? So that's why the option C here is correct. Yeah, someone has already answered that. Yeah, that's correct. So here option C is correct. Okay. I hope you guys understood. Is there any doubts or questions? Okay, so let's move to the next question. The leaves of a dendrogram is in a hierarchical clustering represent. I hope you guys understood the or familiar about these terminologies. What exactly the leaves are? What is a dendrogram? Hierarchical clustering. In the lectures explicitly mentioned by the Dr. Pabitra, what is a dendrogram, what is are the leaves, what exactly the clustering hierarchical clustering algorithm is. Okay. Still, we'll also discuss here. There is no issue. Okay. The leaves of a dendrogram in hierarchical clustering represents individual data points, clusters of multiple data points. Yeah, take your time. Please let me know what exactly the correct answer for this question. Also, this question is a very trivial, maybe. If you have seen the lectures, you will get answer easily. Please let me know what exactly the answer for this question. Yes, some students are saying the A. Any other possible answer is there? Okay. So let's see what exactly the hierarchical clustering is. As we have mentioned in our first slides in the introduction section. So in hierarchical clustering, the how what is the process of hierarchical clustering? It does actually. So if we have 10 or 100 data points, so on. So each data point represented as a single cluster. Single cluster. Each of the data point is considered as a single cluster. Firstly, after that, we have to merge two clusters based on their distance. If their distance is minimum, then we are merging two clusters. Similar way, we are merging whatever the uh, uh, distance we are getting from the two of the clusters, then we have merged. After this is the iteration one. In the second iteration as well, we are trying to merge these points till we will get a single cluster. So this is a general process of hierarchical clustering. So this is an bottom up approach. You are going from bottom to up. Another approach is a top down approach. Okay. So this is an dendrogram. We are saying this is an dendrogram. Another is an bottom up. You are considering single clusters, and then you are going down. So likewise, suppose you have all, firstly you have considered all of these points as a single cluster, then you have divided based on they are closed enough, then you have mm, divided, and they are, if they are furthest points, there you are divided in between. Likewise. Okay, so this is an top down approach. So you can observe here that leaves, these are the leaves of this tree. We can see this is an one tree. So leaves of this dendrogram, also we can call as a dendrogram as well. Dendrogram are individual data points. Individual data points. Okay. Clusters of multiple data points, that is not true. So the option A is correct here. Okay. Yeah. Okay. Let's move to the another question. Which of the following is hierarchical clustering algorithm? Single linkage clustering, k-means clustering, DB scan. Yeah. So this is also trivial question. Please let me know which option is correct for this question. Take your time. So please recall what exactly the k-means algorithm does. What is the process? It uses the hierarchical clustering or not? DB scan it's not or not, right? So in the first our introduction also we have discussed the two clustering approaches are there, the hierarchical clustering and the partition based clustering, right? So you may take time and please let me know what could be the correct answer for this question. A, someone saying A. Okay, let's discuss. So here, single linkage cluster. So for the DV scan and the k-means clusters are fall into the partition clustering part. Partition clustering algorithm. Partition means you have a distribution of the points, and you are considering a centroid in the k-means, and based on this centroid or whatever are the closer, they're making a clusters here. Likewise, in the clustering, hierarchical clustering, we have seen that two points has been merged, two clusters are merged based on they're similar. They are, if their distance between the less, then uh, in that case we are trying to merge it and make a one cluster, single cluster. You might be think about that. If if we have two points, in that case, that is fine. We can find a distance between the two exactly points. But here we are saying that we are merging the two clusters based on their distance, based on their distance of the cluster. But you might be think that from which point to which point we need to take the distance while merging the clusters. Are you getting my point? So as we have discussed that, so this is one single 1, 2, 3, 4, 5, 6. So this single, right now these are the single data points, single data points, right? These single data points, we consider each data point as a single cluster, right? And we are taking the distance. Distance means you can take a Euclidean distance or cosine similarity distance, right? Let's take as an Euclidean distance. Okay. And you are trying to get the distance between this point to this point. As of now, this is a single data points, and we have considered one cluster, so you can easily find the distance. Right? So, so are you getting my point? The how we can find the distance? My view are getting. So you have a 2D plot, and you have coordinates, which is an x1 and x2. This is an y1 and y2. So Euclidean distance could be x2. Sorry, I have written this. So you have x1 y1, and another point is an x2 y2. And if you find the distance between these 2 points, then the distance formula, Euclidean distance formula, is x2 minus x1, right? And maybe plus and y2 minus, right, this one, right, plus and y2 minus y1 bracket square. So this is an Euclidean distance formula, right? So in the single point, there is a no issue. You can find directly the distance between the 2 points. But after, so this is the first level that you have done effectively or correctly. But you, in the second level, you have to merge these two clusters. So this one is a cluster one, that is considering the first second level. This one, and in this single cluster there is a two data points are there. These 2 points, 2 points are there. So you might be thinking then from which point to which point we need to take the distance, and based on that, how we can merge and make a cluster, right? So we have to make clusters if the distance between these two clusters are less. So there are three strategies are there. So the first is an average linkage. Say another is an minimum distance, that is a single linkage, or we are also call it a single linkage. And third one is an um, average means, let's take a, I will explain it. And the max distance also we are calling it a complete linkage. Okay. So there are three strategies are there: average distance, minimum distance, maximum distance. Minimum is we can also call as a single linkage. Maximum linkage is an complete linkage. Okay, I will explain here. If you are not understanding or getting confused at any point, please let me know. Okay. Suppose in we have a two clusters right now that we need to find the distance between the two clusters. Right. These are this cluster 1 point, cluster 2 point. Okay. So here the average distance means we are taking a center of this cluster, and then we are finding the distance between these 2 points. This is an average. Okay. So we are taking a centroid of this cluster one, cluster two, and then we are finding that means centroid means that is an average of that particular cluster one and average of cluster two. This is the first methodology. Second one is an second one is in similar way we have points, and okay. So you are taking a distance between closest points. Closest means, so this is the closest point towards this class, to this cluster 2, cluster 1, and this is the closest point to this towards the cluster C1. So we are taking the distance between the closest points in between the cluster 1 and cluster 2. So this is a single linkage. Sorry, single linkage. And the third one is to take the distance between the farthest one. So farthest points means this is an very furthest points in between the clusters. For these clusters C2 and C1, C2 this is the furthest point. For C1 this is the furthest point. So we are taking the distance in this furthest point. So this is a complete linkage. Are you understanding why we are using this strategy and where we are using this strategy? So in hierarchical clustering in dendrogram, we are merging the clusters, are making one single cluster based on this distance formula, distance strategies. So we are finding the distance between two clusters in three different strategy. We can do a average distance, single linkage, complete linkage. So that this answer of this question is an first one. The single linkage clustering is an hierarchical clustering algorithm. So here, not only we have discussed what exactly the single linkage, we also discussed the hierarchical algorithm, what is a dendrogram, what is an other types of the clustering methodology in the hierarchical clustering algorithm, which is an average, complete linkage, single linkage as well. So these are the partition based algorithm. The key message. Okay. Yeah, let's move to the another question. Which of the following is not true about the DB scan algorithm? Yeah, please let me know what exactly the correct option. Yes, anyone? Yes, number of clusters need to be specified in anonymous. Yeah. Say any other answers are possible here? Anyone? Okay. So here, let's understand how the DB scan works. Okay. So as the options you can read, the first option states that density-based algorithm, it requires two parameters, min, PTS, and epsilon, minimum points and the epsilon. The number of clusters needs to be specified in a, it can produce non-convex shaped clusters. Within the options, it has been mentioned what exactly the DB scan is. As we have seen that, let's take as in the distributed points. So here, these 2 points, two parameters, very important in the DB scan. Minimum points and epsilon. In the DB scan, that is a density-based scanning algorithm, that is an what we can say, the clustering algorithm, density-based. So the density-based, how the density is calculating here? Let's discuss about it. We have this much of distribution. If you have considered, if you wanted to find the density of this point, so what you are trying to do, you are drawing a you have a distance, you have a radius distance, you wanted to do a plot, draw a circle. So how you are drawing the circle? Based on the radius, right? From this point to take a distance, this is an radius, and this radius is an epsilon. Okay, what I'm saying, that you have a point, from this point you are drawing a circle which has an radius is an epsilon, right? You are trying to draw a circle here, so it's not as in perfect circle, but it's trying to understand. Please try to understand. Okay, this is and you wanted to see, after that you have to see that in this circle how much points fall into this particular circle. For this particular point, how much points has been fall into this particular circle. That number of points fall into the circle, that defines as a density of this point. Are you getting my point? Yes, Minakshi, you are saying something.
No, sir.
Okay, so here the whatever the points fall into this circle, that is the density for this point. So firstly we are finding the density of each of the point. So this is an object 1, object 2, object 3, object 4, object 5, right? So each of the point is represented as an object 1 we have considered. And then what exactly min points we are using here? Min points is an hyperparameters which is also defined by the user, that is, let's take as an 5. If in this circle the density of a point is greater than or density of a point, particular point I is greater than equal to mean points, then we are calling that point I is a core point. Okay, core point, we are calling as a core point. Understood? Okay. So then we are finding that what is the which points are fall into the core. So but if it is a core, this point is core, and whatever the points as fall into this core, that uh, represented as a cluster 1, and fall into the points mean fall all points fall into this circle. That means these points are connected to this core. Are you getting my point? So this is an the core, and whatever the points is fall into this circle, they are represented this circle as in one cluster. So also we are calling these points as in border points, which are border of the core points. I hope you guys understood, right? So here, while doing this, it automatically, or we can say by learning from the distribution, it gives a number of clusters that is not in the user hand. Actually, user are not providing the we want this much of the clusters. User needs to only adjust the minimum points and the epsilon, how much minimum points if you wanted to specify for a particular cluster, and the epsilon value, how much circle you want, what is the size of the circle you wanted to take. Okay, so these are the true points. Okay, it is a density based, it is has 2 points. It is also give the clusters for the non-convex. Non-convex means they are not in shape of the circle, it is they are shaped like this way or this way, right? And the number of clusters need to be specified in advance. That is not required, that is not true for the dbscan algorithm. Other algorithm it requires. Okay, I hope you guys understood. So here option C is correct for this question. Let's move to the another question. Which of the following clustering algorithm uses a minimal spanning tree? Yes. So let me know which one is correct option for this. So you can observe here that is an it is the options are the complete linkage clustering, single linkage clustering, average linkage clustering, and DB scan. DB, right? So most of the options has been given by for the hierarchical clustering algorithm. That means it falls into the hierarchical clustering. Yeah, some has been given that the option B, which is a single linkage clustering, is true for this question. Let's see which one is. Is there any other possible answer for this question other than B? Others also can respond in the chat box as well. What do you think? Which option is correct? Okay. Yeah. So this clustering minimal spanning tree. First of all, understand what exactly the minimal spanning tree is. Minimal spanning tree means you have a points. Okay. These points represents as a node or vertex in a graph. So we have to draw a graph which is connected, but that graph does not have a cycle. So each point can reach to any point from a graph. Are you understanding? So each any point can reach to any point of the this graph. So let's consider this is one graph. Okay, and there is a no cycle in between them. Let's take this one, this one. Okay, this is a spanning tree. You might be think that why it is this is only the spanning tree. There might be another possible things are there, right? So suppose I can draw other lines. Suppose I have it like this. I have draw, right? You might be think that this yeah this could be a one spanning tree, right? The points are same, but this could be the spanning tree. There are multiple possible of spanning tree for a graph, right? Spanning tree means there is no cycle and any point can reach to any point. It is a connected graph. Okay. So why? Because if you are adding each of the path, each of the addition of the all of these edges, you will get a minimum distance, minimum path compared to all of the spanning possible spanning tree, spanning tree. That so for that tree we are calling as a minimum spanning tree. Suppose you are getting the all addition of the paths you are getting as in 5 and here for the 10. So this one is the minimum. If you are drawing any possible spanning tree, which has an 11, 7, or 8, so among this, all of this spanning tree, you will getting a minimum for this structure of this minimum spanning tree. For this graph, we are calling as an this one is an minimum. That's why we are adding a minimal uh, term here. Minimal spanning tree. Minimal spanning tree. Okay. I hope you guys understood what exactly the minimum standard that we have seen also in our uh, first year maths as well. Okay. Yeah. So where we can use this minimum spanning tree? It is actually used in a single linkage clustering. As you can see, this graph, this graph, okay, and we know that in the single linkage clustering we are finding a closest points distance between the closest points. So this is an closest point. How we are getting the closest point? Which has higher distance between 2 points, we can cut them and make a cluster. Are you getting? So this minimum tree is used in single linkage clustering. This is an correct option for this question. Okay. Okay, let's move to the another question. Distance between two clusters in a single linkage clusters. Single linkage distance between the closest pair. Sorry, distance between the two clusters in a single linkage clusters is defined as distance between the closest pair of points. Yeah, we have discussed many time actually while we discussed in hierarchical clustering algorithm in the first slide as well, and 2 3 times we have discussed. So yeah, many forward has also given that A option is correct. The distance between the closest pair of points between the cluster. B option is the distance between the furthest pair of points between the clusters. So here option A is correct. Is there any doubt in this question why the A option is here? Anyone? Let me know in that case. Okay, let's move to another question. Distance between two clusters in a complete linkage clustering is defined as. So this is also similar question, but if you know the definition of the complete linkage clustering, then you will get a correct one. Distance between the closest pair of points between the cluster, distance between the furthest pair of points between the cluster. Yeah, here is also option B is correct. We have also discussed it. We are finding the distance between the two clusters who has the distance actually calculating in the furthest points. So if you want to find the distance between the two clusters C2 and C2, so you are finding the distance of this point and this point. These 2 points are the furthest or two apart, far from the two between the two clusters, right? So that way for this pair, option B is correct here. Okay, this is the last question. Okay. Which of the following is not true about K-means clustering algorithm? Take your time, please let me know which one is correct option. D. Any other students apart from the Poga D, please can also respond. What do you think? Which option? If it is wrong, that is also okay. Which of the following is not true about K-means clustering algorithm? It is an partitional clustering algorithm. That is true. The final cluster obtained depends on the choice of initial cluster centers. Okay. The number of clusters need to be specified in advance. That is true. And option D, it can generate non-convex cluster shapes. The final cluster often depends on the choice of initial cluster centers. So option B A is correct. That is in partitional based clusters. It partition the distribution. Final clusters obtained depends on the choice of initial cluster centers. Okay, so we need to check. We need to firstly decide which one is the centroid, right? Based on this centroid is an each iteration it updates. Okay, and that centroids is a representation of cluster midpoint. In C option, the number of clusters needs to be specified in advance, right? We need to specify the k value, how much clusters you want, 5, 2, 1. Like it can generate non-convex cluster steps. It can generate non-convex. That means it is stating that it can generate this shape of the cluster, but that is not true. It is mostly works like that. Suppose this is the cluster, this is central point. It finds its closest one. Okay, that is in circular shape, and then it makes a cluster one like this way. Okay. I hope you guys understood. Yeah, that's enough. Here the option D is correct. It can generate non. It cannot be generate. It this is not true actually. It cannot be generate the non-convex clustering shape. Yeah, that's enough for the today. Is there any doubts you have till now, or any questions? You might be think that as we have discussed here, the cluster key value needs to be specified in advance. But how much value we need to, what is the number we can specify over there? 5, 7, 4? How we'll get to know that? And if you get the 4 nodes, how we sure about that 4 clusters are uh, good enough? There is no possibility of the fifth of the cluster. How we can define that, or how we can know that? So there is a one method we can follow, that is an elbow method. Also, Dr. Pavitra has mentioned that seal out score or any other matrix, that is also defined that whatever the clusters we get, those are they good enough or not, based on they are closely interconnected in intra clustering, and inter clustering there is an furthest distance or not. Based on that we can find out. But the k value we can find another method, which is an elbow method. What exactly the elbow method is? That is an elbow method means if you have multiple k values, this is an k value and this is your seal out value. Seal out means that is an Dr. Pabitra has mentioned the equation of that, which is an average of inter intra-cluster distance divided by inter-cluster distance, right? Right. That means they are how much they are closely connected compared to the what is the distance between their further distance between the clusters. Okay. So you have to check for each of the k value from starting from the 2, 3, 4. Let's check their seal out score. The skill out score is very high, then comes to low, low for this one, then it reduces like this way. So this is the elbow you are getting here. Are you getting it? This is elbow. So this point, this k value, it is an good enough. It's treated as an good enough. You can make a 4 clusters from this for this data point, something data. Yeah, this is one method I wanted to mention here. That's why I mentioned it. Okay, yeah, I think that's enough for today. Yeah, thank you. Thanks for the
Sir,
join.
hello, sir, sir,
Yes, Meenakshi.
sir.
Yes, you are audible, Meenakshi.
Yes, sir, sir. I have a doubt, sir.
Yes, go ahead, my Meenakshi.
Sir, in the course outline, there are topics like uh, evaluation, visualization, sequence mining. Are you able to follow, sir? Hello,
Yeah, but I'm not
sir.
getting what exactly you are asking in course where
Sir,
the
sir,
sequence has been
they'll
mentioned.
give like syllabus like no, sir. Course outline for data mining.
Okay, 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 okay.
In that, these three topics are there: evaluation, visualization, and sequence mining. But these topics are not covered by Pabitra sir.
Yeah.
Will there be questions in the exam?
See,
Uh,
that evaluation or visualization,
uh,
and the third point mentioned you,
uh,
that is an overall things actually. It's not as a specific concept.
uh,
See, in the supervised algorithms such as the SVM
yes, sir.
or let's take another example. We have evaluated those models based on the some matrix. We
Okay, sir.
matrix has been mentioned that this is an evaluation part for particular algorithm. So how you can evaluate your clustering algorithm that we have discussed right now, which is an we need to find out the CIL score and
Okay,
based
sir.
on that CIL score. So this is an overall terms. It's not just particular concept.
Okay, sir. Sir,
Visualize. Yeah. Hello.
similarly, sequence mining, then case studies like that they have given, sir.
The sequence mining also how we can suppose let's take as an time series data
Yes, sir.
or if we have a sequence means there is a sequence of the data and from this sequence of the data you are trying to find out the uh, patterns from it, right?
Okay, sir.
So it includes also this clustering part, as
Okay,
Dr. Kavita also mentioned that the DB scan, the algorithm is used for a spatiotemporal points.
okay,
What
okay,
exactly is the spatiotemporal point? The spatiotemporal, which is an continuous data.
okay, okay,
Continuous
sir.
data means you have each period of time you will get some distribution of the points. So
Okay, sir.
this distribution, which represented as a sequence of the data, which is represented as a sequence, and you can use that algorithm. But DB scan is still be patient for that.
Okay,
So
sir.
whatever concept has been taught in these lectures in the week wise, based
Okay,
on
sir.
that you will get the questions most of the time. Okay.
Okay. Sir, I have another doubt, sir.
Yes. Go ahead. Go ahead.
Sir, in the announcements, they have given the questions will be of a multiple choice type, fill in the blanks, and essay type. Do we have a essay type question, sir?
Essay type means that is a short answer. Short answer
Oh,
means you have to write one line question. What could be the things, or that is one word can be possible over there.
oh,
Okay.
that is fill in the blanks, sir.
Filling the blanks. It's not short answer means might be there is an you have given a problem which is an it requires a calculation and you wanted to put a number over there. Are
Oh,
you
a number or some two, three sentences we had to write, sir.
most of the cases it is an number because it is an arithmetic things,
Okay,
so
okay,
doing evaluating the sentence that may be difficult. Might be
oh,
there is an one word is there. There is no as such essay you need to write over there as of my
okay,
knowledge. But
okay,
if you prepare for that, there is no issue, right?
okay.
All of the things, if you are understand the concept in foundational things of the concept, there is no issue how the questions are getting right.
Okay, oh, okay, okay, sir.
Hmm.
Okay, sir. Thank you, sir. Thank you.
Yeah, no issue. Thanks. Okay, yeah. Is there any other doubts? Yeah. So yeah, thanks for joining. You may leave this meeting. Thank you. Yeah. Let's meet in Friday, coming Friday.
Thank you, sir.
Thank you.